You're sitting in a coffee shop, headphones in, supposedly reading, but you're not reading. You're staring at the same sentence for the fourth time because you feel it. That itch on the back of your neck, that prickling sense that someone somewhere in this room is looking at you. You glance up casually, too casually, and there they are. Someone at the corner table, eyes locked on you, looking away a half-second too late to pretend they weren't. How did you know? You didn't hear them. You didn't see them in your peripheral vision. Not really. There was no sound, no smell, no obvious cue. And yet some part of your brain rang an alarm bell before your conscious mind had any evidence at all. Which raises a genuinely strange question, one that scientists have actually spent decades trying to answer, with some deeply unsettling results along the way. Is this a sixth sense? A survival instinct baked into us from a time when being watched meant being hunted? Or is it something far less mystical? And honestly, kind of a trick your own brain is playing on you? Because here's the thing, the answer isn't just, yeah, you're perceptive. The real explanation goes way deeper than that. And once you understand what's actually happening in your skull when you feel eyes on you, you're going to start noticing this sensation everywhere and questioning almost every time you've ever trusted it. Let's start with the obvious question, the gaze thing. Human beings are, without exaggeration, the best gaze detectors in the entire animal kingdom. Not the best at seeing in general, birds of prey wreck us on visual acuity, but the best specifically at detecting where another creature's eyes are pointed. There's a reason for this, and it's a little humbling. Our eyes are unusual. Most animals have dark irises set in dark sclera, the white part, which camouflages the direction of their gaze, useful if you're a gazelle and don't want a lion knowing exactly when you've clocked it. Humans are the opposite. We evolved a stark white sclera around a comparatively small contrasting iris, which makes our gaze direction incredibly easy to read from a distance. Researchers call this the Cooperative Eye Hypothesis, and it suggests our eyes basically evolved to be readable, to broadcast where our attention is so that other humans in our group could follow it. It's a feature that only makes sense in a species that survive by working together, watching each other's back, literally. So from birth, almost, your brain is hyper-tuned to scan for eyes. Studies on infants, including a widely cited set of experiments out of the University of Sussex, have shown that babies as young as a few days old will preferentially look at a face with open eyes over one with closed eyes and will track a gaze direction well before they can do almost anything else with their vision. That's not learned behavior, that's hardware. You came pre-installed with a gaze detector, and it's been running in the background of your brain every waking moment of your life since, which starts to explain part of the coffee shop moment. Your peripheral vision is much worse at picking out detail than your central vision, but it is disproportionately good, almost eerily good, at picking out motion and, specifically, the particular pattern of a human face. There's a phenomenon researchers sometimes describe as the face in the crowd effect, where a face, especially one that's oriented toward you, will essentially jump out of a visual scene faster than almost anything else in it, even when you're not consciously looking for it. Some of you already know this. You're the ones who can spot the one person staring at you across a packed room in about half a second, and you've probably assumed it's some special intuition. It's not intuition, it's a specialized visual circuit doing exactly the job it evolved to do. But, and this is where it gets interesting, that explains why you can detect a stare quickly once your eyes land near it. It does not fully explain the sensation of feeling watched before you've consciously looked at all. The prediction machine. Here's a way to think about your brain that a lot of people find unintuitive at first. Your brain is not a camera that passively records the world and then reacts. It's a prediction engine, constantly building a working model of your environment and constantly updating that model, often before your conscious awareness has caught up. Neuroscientists sometimes call this predictive processing, and it's been one of the more influential frameworks in cognitive science over the last 15 years or so, with researchers like Andy Clark at the University of Sussex writing extensively about how much of perception is really the brain's best guess, checked and corrected against incoming sensory data. What does that mean for the watched feeling? It means your brain doesn't need full conscious confirmation of a stare to start reacting to the possibility of one. Peripheral vision, even blurry, low-resolution peripheral vision, is still sending raw data to your visual cortex. Your brain is running that data through pattern recognition circuitry that specializes in faces and eyes, the same circuitry we just talked about, and if there's even a rough statistical match for face oriented toward me, your nervous system can trigger a low-level alert before that information ever becomes a clear, conscious thought. You don't think there's a person looking at me, you just feel unsettled. The conclusion arrives before the reasoning does. because biologically, feeling unsettled first and figuring out why second was often the safer order of operations. This is where the survival angle comes in, and it's worth sitting with for a second, because it's a little unnerving once you actually picture it. For most of human evolutionary history, being watched by an unseen observer was not a neutral event. It could mean a predator. It could mean a rival group. It could mean danger you hadn't yet consciously registered. A nervous system that waited for full, certain conscious proof before reacting to a possible threat was a nervous system that sometimes reacted too late. So evolution appears to have favored a system that errs on the side of false alarms, one that will happily make you feel watched 100 times when nobody's actually looking, if it means it never misses the one time someone genuinely is. Researchers sometimes refer to this general design principle as error management theory, a concept popularized in evolutionary psychology by researchers including Marty Hasselton and David Buss in work published in the early 2000s. The basic idea is that when the cost of missing a real threat is much higher than the cost of a false alarm, natural selection favors systems that are trigger-happy. Smoke detectors, not judges, they're not trying to be accurate. They're trying to never let the real fire slip through, even if that means going off when you're just making toast, which means, statistically, most of the time you feel watched, you're wrong. And that's actually the first hint of something a little more uncomfortable that we're going to come back to later, because if your brain is built to cry wolf on purpose, that has some strange implications for how much you should trust your own gut feelings in general. But let's stay with the coffee shop for one more second, because there's a piece of this we haven't touched yet, the part where this feeling doesn't just happen with strangers nearby. It happens when you're completely alone, in an empty house at night, and you'd swear something is watching you from the dark. And that version of the feeling turns out to run on a slightly different and honestly stranger mechanism entirely. The empty house thing. This is where it stops being purely about eyes and faces, because obviously if you're alone in a dark room, there's no face to detect, no peripheral flicker of a stranger's gaze. And yet plenty of people report the exact same prickling hair-on-the-arm sensation when they're home alone at night as they do when someone's actually staring at them in a coffee shop. So something else has to be going on. A lot of researchers point to a much simpler culprit here, one that's almost anticlimactic compared to evolutionary survival circuits and ancient prediction machines: ambiguity. Your brain despises unresolved sensory ambiguity almost as much as it despises actual danger, and it treats the two similarly. In a dark, quiet room, your senses are starved. You can't see clearly, sounds are muffled or absent. Your brain, which is used to a constant stream of confirming data about its environment, suddenly has almost none. And a brain running on very little data doesn't default to nothing is happening. It defaults to filling in the blanks, and it tends to fill them in with whatever scenario would have been most dangerous to get wrong. There's actually a name for a related, more extreme version of this phenomenon, one that neuroscientists find genuinely fascinating. It's sometimes called sensed presence, or in clinical literature, the third man factor, a term borrowed from mountaineering and polar exploration, where extreme explorers in isolated, exhausting conditions have reported an overwhelming, vivid sensation of a companion walking beside them who wasn't physically there. Shackleton famously described this during his Antarctic expedition. Researchers, including work summarized by neuroscientist John Geiger and separately explored by Swiss neurologist Olaf Blanke, have connected this to a breakdown in how the brain integrates sensory and spatial information about your own body under conditions of extreme stress, sleep deprivation, or sensory deprivation. Blanke's work at the Swiss Federal Institute of Technology in Lausanne even managed to induce a milder version of this sensation in a lab, using a robotic device that created a slight delay between a person's movements and the touch feedback they received, essentially glitching the brain's sense of where its own body ends and the world begins. Participants reported feeling like someone was standing behind them, touching their back, when nobody was there at all. Now, you're probably not climbing Everest solo or hooked up to a sensory delay robot, but the same basic circuitry is present in a much smaller dose every time you're alone in a dimly lit house, and your brain starts quietly asking, with no data to answer the question, is something else in this space with me? And because the cost of guessing wrong in that scenario historically could have been fatal, your nervous system doesn't wait for proof. It just makes you uneasy first and lets you go looking for proof second, which is exactly the same design principle from the coffee shop, just running on darkness and silence instead of on blurry peripheral vision. The other people problem. Here's a piece of this that most people never think about because it feels almost too simple to be the answer to anything. You're not actually as good at knowing when you're being watched as you think you are, and this has been tested pretty rigorously in ways that should make you a little suspicious of your own confidence the next time you're sure someone's staring. In a series of experiments run out of the University of Sydney, researchers led by psychologist Colin Clifford tracked exactly how good people were at judging whether a face in front of them was looking directly at them or just slightly off to the side. And the results were interesting for two reasons. First, people were shockingly precise at very close range. Within about a couple of degrees of gaze angle, they could tell whether someone was truly looking at them. But second, and more importantly, that precision fell apart dramatically as distance increased, which makes sense, because visual resolution of something as fine as eye direction degrades fast over distance. Past a certain range, people were essentially guessing, but they didn't feel like they were guessing. Their confidence stayed high, even as their accuracy collapsed. That gap between confidence and accuracy is frankly the whole story here. It's not that you have a magical antenna for detecting stares from across a room with pinpoint accuracy, it's that your brain generates a strong, convincing feeling of certainty, regardless of whether it actually has good information. The feeling of being watched and the fact of being watched are two separate systems, loosely correlated at best, and your conscious mind doesn't get a reliable readout of which one it's currently experiencing, which brings us finally to the uncomfortable part. The part where this whole topic stops being a fun bit of brain trivia and starts saying something a little unflattering about how we operate day to day. Because if this system is a smoke detector, not a judge, if it's designed by evolution to fire early and fire often, with confidence completely detached from accuracy, then think about how many decisions in your life get quietly steered by this exact feeling. The job interview where you were sure the panel was judging you harshly, and maybe they weren't. The presentation where you felt every eye in the room boring into you with disapproval when half the room was thinking about lunch. Social anxiety in a lot of clinical models isn't some entirely separate malfunction bolted onto your brain. It's this same ancient gaze detection, threat prediction machinery running in overdrive, treating ambiguous social situations the way your ancestors' brains treated a rustling bush. Researchers studying social anxiety disorder, including work published through Harvard Medical School's affiliated research programs, have specifically pointed to hyperactive threat detection in gaze processing as a contributing factor in how anxious individuals overestimate how closely and how critically they're being observed by others. So that prickling feeling at the coffee shop, and the prickling feeling in the dark, empty house, and the prickling feeling in a meeting where you're positive everyone's silently judging your idea, these might all be cousins, different flavors of the exact same overzealous alarm system, a system that has kept human beings alive for a very long time precisely because it doesn't care about being wrong. It only cares about not being wrong at the wrong moment. And here's the strange, almost circular twist in all of this. Sometimes the feeling is accurate. Sometimes you really are being watched, and your brain really did pick up on some faint subliminal cue, a shift in ambient sound, a shadow shape, a flicker of motion at the edge of vision that never rose to conscious awareness but still got processed and acted on. That's not mystical either. It's just your nervous system doing exactly what predictive processing describes, integrating tiny fragments of real evidence below the threshold of conscious thought, which means you can never fully write the feeling off as pure noise, and you can never fully trust it as pure signal. It sits in this permanent gray zone, and your brain seems almost content to leave it there. So back to that coffee shop, you glance up. You catch the stranger's eyes a half second too late to pretend you didn't notice. And in that tiny moment, an entire evolutionary architecture has just fired off in your skull, gaze detection circuitry older than language, a prediction engine guessing at the world with incomplete data, an alarm system that would rather embarrass you 100 times than fail you once. All of it, compressed into a feeling so fast and so simple that it just registers as a shiver on the back of your neck. Maybe that's the real answer to the question we opened with. You didn't develop some sixth sense for being watched. You developed something a little more humbling, a brain that decided, a long time ago, it would rather make you a little paranoid for your entire life than risk missing the one gaze that actually mattered. And the next time that feeling creeps up your spine in an empty room or across a crowded cafe, you might not be able to tell whether it's real, but now you know exactly why your body isn't waiting around to find out.